I'm a professor with the software engineering program here at Carnegie Mellon. I'm in fact brand new, I just started. We're going to tell you today about our PhD program in software engineering and why you should join us. With me is Jonathan Aldrich. He's another professor affiliated with the program, and in fact you're the co-director of the program, of the PhD program in software engineering, and Michael Moss, who is a student in our program. So what do you work on, Michael?
Well, at the broadest level, I work in security, and I work in security with Jonathan, and I'm also co-advised by Bill Shirless. More specifically, I work on trying to develop a theory of sandboxing, and this is a topic that I've been working on for a while. I've been working in security for about 10 years, and before I started at Carnegie Mellon, I worked at a large aerospace company where I worked for 5 years. And I started looking at some of the topics that I'm now working on scientifically when I was in industry. And I also continued to collaborate with my former employer, which is fairly interesting.
One thing that appealed to me about CMU is that collaboration both with industry and also within different areas of computer science here in the school. When I came here, I was already cross-disciplinary myself, at least within CS, working at kind of the boundary of programming languages and software engineering. But when I came here, I discovered how much strength there was, not just in software engineering, but also in the broader areas within the School of Computer Science. For example, from my colleagues in programming languages and logic, I learned about linear logics and then found immediate application to an area that's very dear to my heart, which is understanding API usage and helping programmers to more carefully declare the way that an API should be used, the sequence of operations you can use and so on. And so we found ways of taking a software engineering concepts that you might express in a state machine of the design of a software system and expressing them using these linear logic formalisms in a way that we could actually verify people are using this code correctly. So that was a real insight and an exciting an exciting spur to my own research.
Carnegie Mellon ecosystem.
It's good to know. So if you liked what you heard, you're interested in joining the program, I think it's really exciting, you should send an application to the PhD program in software engineering. Whether you're an undergrad and you're just going right to graduate school, or you've been in industry for several years, we'd be really excited to hear from you.
Absolutely.
But it's part of this broader community of researchers who study all kinds of things. I mean, the School of Computer Science is quite large. So if you want to talk to somebody about programming languages, about databases, about security, you have that option, which I find really exciting in terms of the research opportunities that it gives me in terms of my own research program.
Now, what is it that you work on?
So I work on the issues of software quality, kind of writ large. How do we build systems that can evolve and that can exist in the real world over time, that demonstrate really measurable quality in sort of an important and substantive way. And in particular, I work right now on automatically fixing bugs in those real world systems. So in C programs of up to millions of lines of code. And I'm really interested in this problem in a practical sense because bugs in software are a huge problem. They're costing our economy tens of billions of dollars every year. And right now, the state of the practice is that human developers have to dedicate their time to fixing them. And it seems like a very intractable problem, but it's no longer feasible, really, to expect humans to do all that work. So I work on ways to combine random search algorithms, guided by software engineering heuristics and some program analysis techniques, to automatically find patches for bugs in programs in a way that scales to those big systems, while maintaining human competitive costs, both in terms of time and money. But you can see that covers a lot of ground, both in software engineering and in programming languages and security implications and human factors, and so it's really great for me to have the option to work within this core of people who are really dedicated to the issue of SE research while having all those other opportunities at my disposal. And I think CMU is really unique in that respect. I think it's something really special about the Carnegie Mellon software engineering program.
Yes, I agree, and I think what this pulls into me is the history of software engineering at Carnegie Mellon. Going back a number of years, the foundation of the Software Engineering Institute, building founding completely new areas of software engineering, such as software architecture. In fact, my own thesis research was inspired by reading some papers that David Garland and Mary Shaw had written in their seminal work that really founded that field of software architecture. More recently, I've been inspired by work that faculty like Jim Herbslove have been doing in mining software repositories, and more broadly in empirical approaches to software engineering, linkages to human-computer interaction, where Brad Myers has studied properties of languages and software tools. And that has inspired some more of my own research. Going back to this question of APIs, we've now turned from verification to looking at the impact of our tools in practice. Can we actually help developers become more productive, and can we measure that in the laboratory setting using some of these techniques? Coming out of this history of software engineering was really a feeling among the faculty 10 years ago now to start this PhD program, which is what Michael Mass is now a part of.
Right, so the PhD program here lasts about 5 years, and it includes both people who are fresh out of undergrad and people who have industrial experience like I do. That mix is extremely unique, and it's extremely helpful. And one of the reasons why it's really helpful is because at Carnegie Mellon we build things. We don't just put it on a whiteboard and then write a paper, publish a paper, and then stop working on it. We actually try to make it real. So as an example of that, I was talking earlier about how I'm trying to develop a theory of sandboxing. While I was doing that, I discovered that there was a type of sandboxing that nobody was doing yet. So I actually built that sandbox, and then I collaborated with my former employer to test it. And now they're actually looking at using that sandbox in the day-to-day within the enterprise. So that's an example of how, while I was doing science, we came up with a way where we were able to use an external collaboration to actually do something concrete and practical as well.
I think that that's true across the whole school. I think that's been a history at CMU of building things. And
Absolutely.
when we started this conversation, we had to shut the door because a robot was driving by. And that happens sort of more than you might expect.
That's right.
Just to build sandbox to make sure that it actually works, and build your robots to make sure that they actually work. I think it's really fun.
Right.
It's a cool thing about working here.
Another great thing, in addition to just building things, though, is that Carnegie Mellon has a culture of feedback. So within the School of Computer Science as a whole, there's a formal mechanism for graduate students to get feedback from their faculty advisors and the faculty within their department as a whole every single semester. So at the end of every semester, I get a letter that's written to me by the faculty in my department that tells me whether or not they think I made adequate progress within the PhD program that semester, and also giving me guidance on how I can make better progress going into the future and how I can readjust to remain successful.
And what's interesting is, from the faculty perspective, that letter it's coming from your advisors, but it's really coming from all of the faculty in the program. We meet, we have actually quite a long meeting because we discuss every single student in the program. Our students generally are doing just fine, but this gives us a chance to understand what every student is doing. It's a way of fostering that collaboration, because we learn, oh, you're doing that. Oh, well, I can contribute something from my area of programming languages to your area that maybe we should talk about this, right? Or if a student is struggling in some way, then you have the ideas from all the faculty and how to resolve that problem. So I think it was really impressive to me, how much time and effort the faculty really put in as part of the culture here.
Yeah, I think sometimes PhD programs have a reputation, being a PhD student can have this reputation that you're just in your lab without any feedback, working for hours a day with your advisor off in the ether, showing up every 2 years to tell you that you're not doing enough. And I don't think it's like that here at all. It's really built into the culture. I mean, across the whole school. So I also supervise students in other departments, and it's been made very clear that one of the important obligations there is that I participate in that process for that department's students, because at CMU we take that really seriously. You're not sent off and checked in with every 2 years. We're providing feedback because we want the students to succeed.
Well, that's also really helpful in maintaining a healthy work balance within the program. So I do work longer hours in the PhD program than I did when I was in industry, but I do not work overwhelming hours. I still maintain some of the hobbies that I had when I was in industry, not all of them, but some of them. And I also get to go out and do things on Friday and Saturday night. I'm not locked in the lab constantly. So I actually get to go out and do enough stuff and have enough of a work-life balance that I met my fiance while I was in this program.
Wow.
Yeah, so she's not in the program.
She's not in the program actually, so she's not affiliated with Carnegie Mellon at all. So that means that I get to go out enough that I meet people that are not even at Carnegie Mellon.
That's a good sign, I
Right.
think.
I'm not trapped within just the Carnegie Mellon ecosystem.
It's good to know. So if you liked what you heard, you're interested in joining the program, you think it's really exciting, and you should send an application to the PhD program in software engineering. Whether you're an undergrad and you're just going right to graduate school, or you've been in industry for several years, we'd be really excited to hear from you.
Absolutely.